We'll just wait because we can see if there's any attendees as well.
I'll turn off the video when you start the video, Lewis.
Mm-hmm. All right, let's make a start because this is going to be available on demand as well. So hi, everyone, and welcome to today's Ask the Expert session. My name is Lewis Gilday. I'm a technical sales specialist here at Autodesk, and I'm joined today by Kevin Mortsfield.
Hi, I'm Kevin Mortsfield. I'm also a technical sales specialist out of the Tampa, Florida area, but been in the industry since 1995. Worked at 3D Systems back in 1995. Worked there for about 7 years. Worked out of a company out of Michigan, Masco Corporation, for a decade, and also worked for some other additive companies. So that's a little bit about my background. I got an engineering degree from Eastern Michigan University, and glad to be on today to talk about some Netfabb.
Great, thanks, Kevin. And my background, as I said, I'm a technical sales specialist, but 13 years in industry, mostly aerospace engineering. So everything from metallurgy to forging, casting, machining, and everything else in between as well. So we're going to start today's session by taking you through a workflow from Fusion to Netfabb, just as a little preamble, get you thinking about the products and thinking about the sorts of questions that you want to ask us. And then we'll follow that 15-minute workflow with open forum questions. You can ask us whatever you want in the chat. So down the bottom, there is a chat function. You can open that up, type in your questions, and we'll answer them live. All right, so start with the workflow video, get you guys thinking, and we'll talk to you in a few.
Today we're going to spend about 15 to 20 minutes focused on improving your additive workflows using solutions from Autodesk's Make portfolio. From designing a part in Generative Design for Fusion 360 to preparing the part for metal additive in Netfabb. Welcome to the latest in this series of webinars. My name is Lewis Gilday and I'm a manufacturing subject matter expert at Autodesk. If you enjoy today's content and want to learn more, there are many ways in which you can do this. Visit our advanced manufacturing pages on LinkedIn, YouTube, Facebook, Instagram, and Twitter. Or reach out to me on LinkedIn for more additive insights. I'll show this slide again at the end, so don't worry if you don't catch it now. Also, feel free to ask questions during the webinar, and we'll do our best to reach out and answer them after the webinar has ended. First things first, let's talk about additive manufacturing in general. Commonly known as 3D printing, it encompasses many different technologies, processes, and materials. This infographic from 3D Hubs shows all of the main printing technologies, as well as the leading names making those machines. Today we'll be focusing on just one of these printing technologies, but it's important to note that Autodesk has software solutions to drive all of the technology you see here, mostly inside of our specialty additive brand, Netfabb. The printing method we're looking at is direct metal laser sintering, or DMLS for short. This method, as the name suggests, sinters metal powder selectively, layer by layer, to build up a component. This type of manufacturing allows for a huge range of design possibilities that otherwise would not be able to be considered if making a part using traditional techniques. But it also brings with it its own challenges. Foremost of these challenges is, how do I design a part for a process with different manufacturing constraints? Often additive also comes with the tagline, complexity for free, which is somewhat true, but raises the question, how do I go about increasing complexity without putting in hours upon hours of extra design time, ultimately leading to an increased time to market for my product? As a starting point for my part, I'm going to use Generative Design inside of Fusion 360. Generative Design allows engineers to define a problem and partner with their computer to find solutions. Inputs to Generative Design are geometry, structural loads, materials, factor of safety, and manufacturing method. The geometry we see here on screen is preserve in green and obstacle in red. This example part comes with Fusion and can be found in the ready-to-generate state with all of the constraints preset. Fusion harnesses the power of the cloud to compute hundreds of possible outcomes for my problem and gives me ways to filter and sort the outcomes to find the most suited. Here we can see all of the manufacturing methods that it's currently possible to consider when creating a study. As we're focusing on additive, I'm going to turn these off to start refining my results. Here I'm using a scatter graph that displays factor of safety over mass. The different color points represent materials. I can hover over an outcome to see a preview, or open the preview fully to navigate around the component. I've been able to generate and choose a design that fulfills my design requirements whilst also making sure it's manufacturable. And once I'm finished in Generative Design, I'm able to export Parasolid model data out to Fusion to continue editing. Here I am able to create a manufacturing model, an interim stage before the finished shape. The reason for this is that 3D printing in metal still requires finishing on important faces. The surface roughness of the as-printed part can be likened to a casting, so I'm adding stock to some areas that require a sliding or mating fit with other components. Once I'm done making minor edits, I can use the Netfabb button inside of Fusion to send my file to prepare for printing. Access to the Netfabb button can be acquired by installing the Netfabb app for Fusion from the Fusion App Store. It's free. Just go to the Fusion App Store and search Netfabb. So long as you have an active license to Netfabb, this button will allow you to export your designs straight to Netfabb from Fusion 360. My design is now in Netfabb, and I'm ready to start prepping for additively manufacturing this part. Firstly, I'm going to select a machine on which to manufacture the part. I have my favorite machines already available to me in the My Machines tab. But if the machine I want isn't shown here, I can go to My Machines on the ribbon menu. Here I am able to edit the machines I see when I open the software. I can add to this list from an extensive library of 3D printers that come with the software. I can even edit the behavior of my Netfabb so that it opens certain machines by default when I open the software. In this instance, I need a direct metal laser sintering machine with a medium-size platform to print in aluminium. The machine loads, and I am able to drag and drop my part into the machine workspace. From here, I still need to orient, place, and support my component on the platform before it is ready for printing. Options for doing these tasks are now displayed on the right-hand side. These key calculations will be analysing the triangles that the part is comprised of. Therefore, the less triangles, the less computing time. However, reducing triangles will also mean losing accuracy of the part. This is where having background model data can help. Netfabb triangulated the model upon it entering the software, but it also kept the model data. This allows us to retessellate the model at any point, meaning we are able to calculate on a low resolution model and then turn the resolution back up when we come to print, saving us valuable calculation time and getting us to the machine faster. Once retessellated, the part needs to be oriented. Orientation is a key piece of the additive manufacturing puzzle and can affect the outcome of the print drastically. The orientation module allows you to search for different possible part orientations and choose based on supported area, support volume, print height, outbox volume, and center of gravity height. Now I have my part oriented, I can use the grab handles on the part to position it on the build plate. Supports must be added to overhanging areas on the part to prevent build failure. Opening the support editor gives me access to support generation features. Supports can be created manually with bars, polylines, or volume. Alternatively, there are support scripts which can quickly populate the necessary supports based on some predefined rules and parameters. Netfabb comes with default scripts which can be easily duplicated and edited to suit the individual conditions present in different printers with different materials, as is being shown here. Scripts contain many different parameters, which makes them almost infinitely configurable. Wall type, hole spacing, and size, as well as connection points between parts and platform, can be established. And once you're happy with your script and how it applies to your parts, you can apply it to any other part geometry with just a click. Furthermore, supports that are applied to the part can be edited in place. For example, here I can angle the supports out and away from the part to minimize part cleanup after printing. Note that, with my script saved, I can execute it from outside of the support creation module at any time by going up to the ribbon and running it from there. I'm happy with how my supports look, so now it's almost time to print. Let's not forget to turn the resolution back up on my part first though. Once I've done this, I just need to refresh the attached support so that the supports align properly with the new higher fidelity geometry. As well as containing useful part prep tools, the context area to the right also has information about the machine settings that will be applied to this print. Here we can see that the machine tool manufacturer's default setting for my material choice is applied to this part. Others can also be chosen from a library of defaults. Custom settings may also be applied. Settings applied, it's time to slice the part. Toolpath visualization will allow us to view individual slices of the build before we send it to the machine. Here we can see the supports and the part slices layer by layer. They contain the hatches and contours that the laser will follow when sintering our component. Not every single layer is displayed, rather a layer interval, which can also be altered to see more or fewer layers visualized. Further analysis of our build can be done prior to printing by sending the build to the simulation utility for Netfabb. In the utility, you can perform simulations for metal additive build processes, which allows you to predict stresses and distortion. This thermomechanical analysis is then used to tell the engineer about potential issues and failed builds before making that costly error on the machine. Here we see the part being built in layer intervals. It will even show what happens when the part is removed from the platform. The color mapping on the part is displaying displacement. This is one of many result types that can be shown. The AM engineer can use these to problem solve for that build and get to the root of any failures, such as recoater interference, support structure failure, or warpage that takes the part out of tolerance. Once your process is understood, these tasks that I have showcased today can become tedious and repetitive, which brings us to our final topic for today's webinar, automation. Netfabb and Fusion give you the tools to automate some of your workflow. Using a scripting language inside of Netfabb called Lua, I can automate the print preparation so that I can orient, place on a build platform, and also support in just one click. Creation of custom applications in Netfabb is also possible, allowing you to personalize your experience of the software. Netfabb comes with preloaded examples of Lua scripts to help get you started. Edits to these scripts can be applied and checked for syntax errors before running. For even more automation, it's also possible to use the Fusion API to edit the Netfabb app itself, so that when I send a part to Netfabb from Fusion, it runs the script and we're left with the finished print job ready to export to the machine. Here we can see this happening in real time. I've selected the part to export to Netfabb and the script that I want Netfabb to run on it. This opens Netfabb and after a few moments calculates my orientation, my supports, and also opens my machine and places it on the build platform. This advanced level of automation cuts out on wasted time for day-to-day operations, allowing you to focus on innovation activities and driving your business forward. So there we have it, faster additive build preparation by streamlining your digital workflows. Thank you for joining us today. I hope you've enjoyed the webinar and found it informative. Again, if you'd like to find out more about our advanced manufacturing products, get in touch with us on social media or find me on LinkedIn.
All right, hopefully that was informative for you guys and got you thinking about the process of doing print preparation for your 3D printing. Now we'll open it up for open forum Q&A with Kevin and I. And we have one in the chat already from Sai. Thank you, Sai, for the question. It says, the orientation of part affects the surface finish, so which is more efficient? Process involving less support structure or process having proper orientation for good surface finish and also that avoid staircase error? Do you want to comment on that, Kevin? What's more efficient? Is it more efficient to have less supports or is it more efficient to get the right orientation?
Yeah, that's you know, as an application engineer, putting the supports on there, you really have to look at the pluses and minuses. If you have a surface that's really important, you know, you're going to want to orientate that part with the supports not on that surface. So it's up to the engineer basically for that. Yeah, you're going to be more efficient if you have less support and you have that part in the Z height lower. So there's a lot of pluses and minuses. It really depends on the geometry and what you're trying to create.
Yeah, I would add to that. It's a case by case basis, right? If
Yep.
you know that you're going to be able to do some finishing after the fact, if you have an all over surface finishing, such as, like tumbling or shot peening or blasting or something like that, then it does become less important. If you know you don't have that stuff available to you, you're probably going to orient in such a way that reduces the amount of finishing that you have to do to it. But that's a good question. Post processing always is factored in to a lot of your decisions up front, in metal for sure, and also in other processes too. Great. I can actually unmute some of you guys as well. We have a fairly small group here, so if you want to actually speak and not just in the chat, I could. If you raise your hand, I can allow you to talk as well. We'll see if we have anyone brave enough.
Also keep in mind the supporting, you can edit. So when you're creating the supports and an orientation and you have metal parts, we have that editing capability where you can move the support off a feature, for example, onto the platform, so you can keep from marring that surface when you clean up the parts. Just wanted to add that. And please ask any questions if you guys have on any editing or finishing of parts, and me and Louis would be glad to answer.
Yeah, and although we've shown this particular workflow today is a metal additive process, obviously, our solutions cover more than just this technology. And Kevin and I see all sorts of 3D printing technologies on a daily basis. So everything from MJF to DMLS and everything in between, FDM, SLS, those sorts of processes, and also the functionality that goes along with those processes. So we cover things like automatic 3D packing. We also cover like optimizing those packing strategies for scanline in those machines as well. What else do we cover, Kevin?
I mean, we also cover Netfabb Ultimate. You're going to get simulation in that video that Louis had done, where we showed you ways a metal part could have some issues such as displacement and things. We have the ability to, with the Netfabb Ultimate tier, you'll get a simulation LT version where you can simulate a metal 3D printed part, on a part per basis. Now, if you do a full build, we have a software called Netfabb Local Simulation that you would need, but you do get the option with the Netfabb tier, Netfabb Ultimate. We have 3 tiers: Standard, Premium, and Ultimate. And so that's a good point there. You definitely want that if you have the metal 3D printer, the Ultimate tier.
And Ultimate allows you to take advantage of some of the other functionality that we have for design for additive as well. So being able to create lattice geometries inside of your component, both uniform and changeable. So you're able to create load optimized lattice structures inside of a component and create a skin on the outside as well. Sai has another question here. They're saying, how can I repair the mesh most effectively? So there's many ways inside of Netfabb that you can repair meshes. We do provide automated mesh fixing, and these automated scripts are, I would say, very effective at repairing meshes. You have a particularly untidy mesh, however, we do have the tools inside of there that will allow you to do, refining of meshes, smoothing, blending of meshes as well. So that's all inside of Netfabb. And it's important to note that, we inside of Netfabb can work with model files as well. So it does tessellate the model file when it comes in, but it keeps that model data in the background. So we can directly import, many, many different formats, all the neutral file formats like STEP and IGES, but then also it can import Creo files, it can import NX files, it can import Rhino files, SolidWorks parts, it can, import CATIA parts. So not just the fact that it takes meshes and can repair them, but oftentimes I see a lot of issues in translation. So from going from your native CAD environment into a build processor for 3D printing, you see a lot of issues in translation. And a lot of these can be mitigated by just importing the native CAD geometry straight into Netfabb, and it's able to read and tessellate those files directly.
Yeah, great answer, Lewis. I mean, when we open up files in Netfabb, you have these repair scripts. So when you load that part, that script can automatically be run if you check that box to do that. So you're talking 90% of the time that's going to fix the file. And then, if you have a file that's pretty corrupt, we have manual ways of fixing and being able to go in there and edit that mesh. So, definitely you'll be able to fix part files.
Thank you, Si, for your questions so far. Let's see if anyone's brave enough to talk. You can raise your hand and I can unmute you as well. So let us know. And I can also comment on some of the presentations from yesterday as well. I thought the presentation from Fathom was particularly interesting, where they were using 3D printing in the new product introduction cycle. And this is a trend that I see in the industry, is that people are starting to realize that additive is not just for prototyping anymore. You can still use it for prototyping for sure, and that's a good use, a valid use of additive manufacturing. But I see this evolution of additive in all the stages of manufacturing. So it's definitely involved and has been involved for a number of years in the prototyping of components. But now we're also seeing additive, and we saw this on the Fathom webinar yesterday, additive being used in bridge production, gap production, whereby you've decided on a concept and you're forging ahead with that concept. That's the one that you're going to manufacture, but there's a lead time for you to get to that manufacturing process and get the tools required for that manufacturing. And in the meantime, additive is great. Bridge production is the term that I use for it, where you can make hundreds of parts without tooling, and get you into production, sometimes 5 to 8 weeks sooner than you would have done in the past. And that's valuable time that's regained. And then also, in that example, additive is being used in end use parts as well, and in production, and sometimes to supplement production and improve cycle times. So we're seeing a lot of metal additive being used to create conformal cooling channels in injection molding dies and inserts. And this is a way that you can greatly improve the efficiency of those injection molding parts by reducing cycle times. So additive really is becoming it's starting to be used in every phase of production, from concept all the way through to production. So it's really very interesting, and it's good to see Fathom there using that. Another question from Sai. would like to know more about the strength of bodies prepared by additive manufacturing and the relationship between the direction of applied load and way it should be printed. So this depends on your printing methodology. Now, I would say in metal additive, you're going to see much denser, more uniform parts because you're firing a laser at a bead, and it's melting that bead, and they're sintering together into a solid component. Now, I certainly have experience of parts when you're printing on a FDM or an FFF, so things like Automaker or carbon machine even, where you have a force moving laterally across and the print direction is this way, then that snaps because the layers are also going that way, and it's like really easy to just snap them parts. You have to be careful in that scenario which way you print, so you have to be mindful of the forces that are applied to it. But yes, some printing technologies are more prone to that than others, that's for sure. The example that I have actually is that the Advanced Manufacturing Centre in Birmingham in the UK, which is my hometown, we were making helping to make a goalie robot. So a robot that had a hand on the end and some imaging equipment, and you would kick a ball at it and it would save your shot. And we printed in this direction, the hand up like this. And of course, the first shot that we took at it, it saved it and snapped the hand because the layers are going in this direction. So you had to change orientation, take that into consideration whilst making that 3D printed hand in that case.
Yeah, definitely with the fused filament fabrication, the machines, pulp makers and machines like that, the hobby machines, yeah, you really have to think about the Z height, like Lewis said, with the layers, delaminating. With SLA, where I have a lot of experience with, the layers are pretty robust because it's more homonymous. All the layers are, they go within each other, when it's cured. But you do see that a lot more with the, filament type printers. Yeah.
This is good. Si's got all the questions. It's helping us out. So any questions, if you guys want to put them in the chat, or I can also allow you to talk and you can talk live. I'm pretty sure there's a raise hand function. If you were to raise your hand, I could allow you to talk and unmute you.
If you're afraid to speak up, you can always email us after, and we'll gladly answer back also.
Yeah, for sure. I'm contactable via my first dot my last name at autodesk.com, so lewis.gilday@autodesk.com. Same with Kevin. We're also, I'm active on LinkedIn, so you can feel free to add me there as well. If you have any questions that you didn't think of during this time and want to ask me afterwards, yeah, for sure. Add me on LinkedIn. Kevin, I think you're pretty active on there too, right?
Yep. Look me up on LinkedIn. Be glad to talk and help anyone out with questions on Netfabb or Autodesk products.
Good stuff. It doesn't look like we've got too many more questions coming in. So I think, Kevin, we can stop the session there. We would like to thank you all for your time. I hope this has been helpful, and hope you've learned some things on this call as well.
Thanks everyone for joining. Appreciate it.
Thanks. Bye for now.